So welcome to the first talk in this year's How To Talks by Postdocs series. Dr. Anna Nagle will be leading today's workshop on Intro to Our Package, Part 1. She received her Ph.D. in biomedical engineering from the University of Cincinnati and is currently a postdoc at VCU in the Mechanical and Nuclear Engineering Department. Please join me in welcoming Dr. Nagle.
So thank you, everyone. I'm so glad you came. And I'd just like to gauge from the audience where you're at. Could you show by raise of hands how many of you already have R on your laptops? Okay, about half. So that will make the first bit of the class a little bit easier. And of those of you who already have it, how many of you have actively used it? Okay, a couple. So that's pretty good. This will be a hands-on workshop, so I'll unfortunately be stuck behind this computer most of the time. So I'm very grateful that Karen and Dana are here to help go around so as you might have issues. I think the first thing we need to do is start downloading R for those of you who don't already have it. Before I do that though, if you can go ahead and open your browsers and go to this link. This will take you to the wiki space I created for this class, and it will have all the other links and information that we'll be covering today. To give you a quick overview of what I want to do today is the very initial basics to start using R for statistical computing. Those of you who have used this might be a little bored, but luckily it looks like there's only 2 of you. And then next week we're going to be doing a little more advanced things that involve downloading outside packages, using outside libraries that aren't just in the R-based package that we will be doing here. So that's how I split this up. And I should mention now that at the end of today's session, we have reviews for you to write. If you can please write down things you would like me to cover next week. It looks like we'll have enough time to cover a number of things. So if there's something you're really aching to know how to do in R for next week, please let me know and hopefully we'll be able to cover it. And even if you're not able to come here next week, as Karen said, all this information will be online, so you can watch it that way. So I'm going to go ahead and click on this link to get to the wiki space page. And then I'm going to click on this link here for the Duke Mirror to download R. Obviously, you have all different computers, so not all of you will be doing quite the same thing as me, but luckily, R is very straightforward to download nowadays, in a way it wasn't 10 years ago. So this is a Windows computer, so I'm just going to click on Windows, click on Install R for the first time, and now I'm going to download R 3.3.1 for Windows. And here it is in the bottom. Does anyone need to back up and show stuff again while I wait for that to download? Depending on your internet connection, you may or may not be quite downloaded yet. But when you have the exe program, just go ahead and click on it. Just use the default options. And it should be fairly straightforward. And at this point, it might be a good time for those of us helping to just go around and make sure everyone's good. With Windows, I should mention that you have the option of downloading 32-bit or 64-bit. Most current Windows computers can run both, so I say go ahead and download both. The 64-bit one is a bit faster, so that's what I tend to use. Anyone having trouble? That's good. All right, so while I wait for this to complete, or for yours to complete, let me tell you a little bit about myself and about why I use R. So I am not a statistician. I will warn you that now, so I might not be able to answer really high-level questions on stats. But as a biomedical engineer at the University of Iowa, we were required to take statistics classes. So, and of course, it's a very useful thing to do. So I went ahead and signed up, and I actually really loved those classes. The professor was Dr. Rao, and he was someone who was really excited to teach, and he was very dedicated to making very clear notes that would guide you through the process. And the first class I had was devoted to downloading R and getting started in it. So when I thought back about what my favorite class was when I was a grad student, it was learning to use R. So that's why I thought it would be a fun thing to teach here. Also very useful. It's something that I continue to use nowadays. So while I don't feel like I'm a total expert in it, certainly for getting started, it's a thing I enjoy using and hope to share with you all. So what is R, real quickly? It's a statistical software, and I have the official terms here. But it's a system for statistical computation and graphics. And if you're advanced in R, you can write your own packages and functions for it. There's something called R Studio where you can do that. That is beyond the level of this class, but there are books coming out constantly on how to create your own packages in R. Likewise, it's a free open source type of functions, so other people are constantly writing their own statistical packages in libraries and functions, and they'll often put those online for free on the R website. So I did include on the Wikispace page the main site. You can search there, and also for the different packages. So usually what you need is probably already been created, and with a bit of searching you can find it. So that's what I really like about R. It actually has more packages than most other statistical software. So to get into why I like using R versus some other statistical packages, scroll down here a little bit. So mostly because it's free and you can use it on any platform. So there are statistical software that we had access to as part of the University of Cincinnati's system, and then I moved here and VCU uses other statistical softwares, but I could just download R on my computers and keep using the one everyone's familiar with. So that's an advantage. And like I said, since it's free and anyone can create new tools in it, I can almost always find what I need. So those are my main reasons for using R. It was inspired by the S environment, if any of you are familiar with that. So you'll notice a lot of the commands use a similar syntax. Now, anyone still downloading? Okay. So, a difference between R and a lot of those other softwares that aren't free is those other softwares, they have people who are hired to create the packages, which might mean that the quality is better, but that hasn't actually been what I've seen. I feel like the quality of all the packages I've used in R have been just as good. R has a large set of volunteers who debug all the code that are submitted to their website. So I have actually never had a problem, even though they're created for free. So that's quite handy. And I would say that the things I use most often in R is doing power analysis. Whenever I'm writing a grant proposal or anything, I need to know what sample size I'll use. So that's what I use the most, but that actually requires downloading a particular library, so that I'll be showing in at the beginning of the next class. Most of the things I'll be showing in this class you can do in things like Excel or MATLAB. They're a little bit harder in those environments, I think. Although I think that also depends with what you're used to. So I believe we have the majority of the class set. So let's go ahead and open R. So I'm gonna go find the desktop on here. All right, so here I have the 32-bit and the 64-bit. Gonna go ahead and open the 64-bit. And let me just arrange this so I can have the notes open as well as the console. And this. Okay. And you may wish to do likewise, so that you can see both what you're writing and what we're taking the notes from. But since I have the notes up here, if you want to fill your whole page with the console, that's completely up to you. So the first thing you should know is the greater than sign dash. That is what you will use all the time in our means definition. So let's quickly just, for an example, use R as a calculator and type in x less than dash square root of 25 plus 7, plus 2. It should equal 7. You notice that when you press enter, it doesn't immediately tell you. That actually depends on what function you're using in R. Most of them don't automatically display, but a few do. So to make sure it actually works, you do have to go ahead and type in x to see the answer. It's right on here. Please raise your hand if that didn't work for you. Okay. So that wasn't that exciting. You could do that in anything. So let's go ahead and make a number sequence, because you're probably going to be using not just a single number like x here. You'll probably be using a vector, which is like a one-dimensional list of numbers. And they might have a pattern. So you can use sequence to make numbers a vector in a pattern. So I'm going to write x is defined by SEQ for sequence of 4 to 15. And now, if I look at what x is, I get all the numbers from 4 to 15, which will come in handy pretty much all the time, I find. Let's say I only wanted the even numbers. One thing I should mention, if I don't want to rewrite everything I just wrote, I can just use the up arrow, and it'll give me back each of the commands I just wrote. So if I click it twice, I get 2 commands to go. So let's say I want only the even numbers, then I can add a comma 2 after the 15 before the end parenthesis, and this will give me only the even numbers. So let's say I don't want my numbers in a pattern, I just need to pick the numbers that were relevant to what I was working on. So for this, I would make a column vector, and I'm going to call this CV, and I'm going to find that as C parenthesis 5, 7, 13, or whatever numbers happen to be relevant. And I guess I have to write an actual dash instead of a 0. Sorry for the typo. Look at Z. And let's say this is what I need a pattern from. I can actually repeat this quite easily. The command is rep. So I'm just going to call the next variable the rep. And I'm going to define that as REP, made the same typo. Parentheses, the comma 3 to repeat those numbers 3 times. And let's look at 3 rep. Hopefully you have something like this. Yes? Okay. So now let's go to something a little more interesting, something that I might actually use in real life. As I'm a biomedical engineer, most of these are going to be the examples to be more towards that application. So do be thinking about how you can use this for your own research that might be outside of that field. But I do a lot of stuff looking at different patients, and I have to calculate their BMI. So I'm going to go ahead and go to the next example and define the weight of my set of patients. And I'm going to make it another column vector. And the weights in kilograms are 60, 72, 57, 90, and 72. And then I have their list of heights. And I'm going to define that as a column vector of their heights in meters, which are 1.75, 1.8, 1.65, 1.9, 1.74, and parentheses. And if you're not familiar with BMI, I should have backed up. It's body mass index. It's a way of trying to determine if someone is overweight or obese or underweight. And it has a equation. BMI is defined as the weight divided by the height squared. And the caret mean squared, which is true in a lot of other languages. And apparently I made a typo, so I'm just going to call this heights. And now it should work. So now I have the list of BMIs. And now I can look at different things about this list of BMIs or other aspects of the patient's, things that you might, on the most simple level, use Excel for. But of course, you can do them here too. So I can get, for example, the sum of the weights. If I put all of them in the elevator, would it ding at me? Probably not. I think elevators can hold more than that much. I can find the mean of the weight, which is often a thing that I would report in when I try to publish a study. I would have the mean standard deviation of the weight. So and with these calls, you'll notice that I don't have to then define them and ask for the answer. It's just outputting the answer right here. The command for standard deviation is simply SP. That one actually is what always trips me up because it's STD in MATLAB and STDev in Excel. So remembering it's only ST, even though that's the easiest thing, is the one I always forget. But luckily, if I forget, R has its own help packages up here. I can Google it. It's always easy to find the answer if I forget the actual name of the function I need. So now, to go a little bit more interesting, let's do a t-test to see if our patient population has, on average, what's considered the ideal BMI, which is 22.5. And so this is looking at the population, and it's trying to determine within this population, on average, would their average be statistically different than a BMI of 22.5. So the command is t.test, parentheses, BMI, comma, mu, equal 22.5. And now if we look at this, some things that you might use are the t-statistic. So that's saying, since it's a negative number, that at least in this particular set, that their average might be a little bit lower than 22.5. But then if you look at the p-value, it's fairly high. It's 0.839, which is to say well above the level of threshold for statistical difference. That's often 0.05, at least in my field. I know that does vary on field by field. Some places will use lower. I've even heard of places using 0.1. But basically, whatever p-value you have, if it's above that level, you cannot reject the null hypothesis that our population average is different than the target. So in this case, we cannot reject that null hypothesis, so we'd say that in this population, we would consider their mean no different from that ideal BMI. DF means degrees of freedom right here. And the actual mean of X, which we had already found earlier, actually, no, we didn't, because we looked at the mean of weight. So the mean of our BMI was 22.29. So I can see why it would report that, well, it might be a little smaller, but statistically it's not a significant difference. That is quite close. So now, to scroll down. One last thing in this section. I'm not going to spend a lot of time on plotting, but it's quite straightforward. And I included a link that will tell you lots more about how to plot. But let's just quick plot this a little bit. So I'm going to plot the height versus BMI. In this command, PCH means picture character, and I believe 2 is triangles right now. And then COL stands for color. And I've decided to do blue because I like blue. You can enter red or green or whatever color you like, of course. And you should get a plot that looks like this. And if you want to go ahead and play with that, change the picture character, change the color, make sure you're comfortable with it. Any questions before I move on to the next example? Okay, so for the next example, on the wiki spaces, I actually uploaded a text document that I would like you to download somewhere on your computer, and I will be doing that up here. Except I don't want it on my browser. I need it actually on the computer. Hopefully this will work. Yes. Okay. And the reason I put this in a text document is because in the previous example, you'll notice we just typed in the numbers. But in real life, that's almost never how I would enter data, because I have a lot of data, and that would be a poor use of time. Most likely, I have it in a text document like this, or maybe an Excel document, and I will directly import it from the document, and I don't have to worry about making a typo or anything else. And you'll notice in this data, we have the ages of the participants in the study, and they're in ascending order. And then we have the sex, and in this case, 0 means female, 1 means male. We just happened to ours, and then I said all the females first. So if I were entering it by hand, I could just use the repeat function that we covered before. And then on the third column, I have response, which is to say, do they have the disease we're studying here, where 0 means yes and 1 means no. Everyone have this downloaded? Not quite.
It opens.
So what I had to do is right-click it and do Save Link As. If I just clicked on it, it only opens here, which was not helpful. So right-click, Save Link As, and then you should be able to download it as a text document. So I'm going to go ahead and close the plot. We don't need that anymore. So the first thing I want to do in R now that I know where my data is, but R doesn't, and I'm just out of curiosity going to use get WD to see where the current directory is. So if I had done that first, I could have downloaded that document directly into that folder, and I wouldn't have to reset anything. But that wouldn't teach you how to change the directory, so I'll give that to. So now that I know that I'm not in the correct directory for my data, I need to change it to that correct directory. One thing I want you to notice is that the slashes in the directory are backslashes. But a lot of times, especially if you're in Windows, it will use the /. And that makes things tricky because R sees the / as a return sign. So it will automatically just change them all in direction. So if I go to downloads, which is where I have the data, hopefully I can find the entire thing. So at least on my computer, if I click here, I can get the address, but it would have the slashes the wrong way. So when I copy and paste it into R, I have to switch them. So let's go ahead and change that directory. So we're going to do set WD. And if you believe it's going to start the same way, could just save some time and copy and paste from here, I believe. And that was in downloads. I see you there. Okay. I'm pretty sure that worked, but just to check, I'm going to do this again. So now I should have R looking in the directory where I have my data. So now I'm going to have it actually read the table. So I'm just going to call the table df. You can call it whatever you want, of course. And I'm going to define that as read.table, parenthesis, and here we would put in the file name. So let me double check I am putting in the right file name. Which is our _ patients. And and that is going to be in parentheses, dot text, comma, header equal true. I should mention that R does notice capitals and lowercase differently from each other, so you do have to be careful to get them consistent. Before I go on, I should mention what the header true says. In the data, you'll notice that the very first line is not data, it's saying what the data is. So we're considering that a header. So I'm telling it that the first line should be text, not numbers. And now let me make sure I actually have the right data. So if this worked, you should be able to write df or whatever you call the data and get the matrix. And the matrix is a two-dimensional list of numbers, so it's a series of vectors. And you'll notice that R put in its own 1, 2, 3, 4, so you know how it's numbering everything. I'm going to script cast this here. So if I want to know what's in a particular vector within that matrix, I could use the $sign. So I say the name of the matrix, df, $sign, and the name of the vector I'm interested in. So I'm going to write response. And it will only tell me that last column. And right now it's considering all these numbers. But really, some of them aren't continuous numbers, they're factors where they can only be 0 or 1. So I'm going to now define another response vector, but this one I'm going to use a capital R since I know R will see it differently. I'm going to define it as a factor vector. So I'm going to call that response, defined as the factor of df $sign response. And let me just make sure that looks like the same thing. Okay, and now you'll notice when it returns, before it just returned the numbers, it thought they were numbers. Now it returns the numbers and it also tells me what level they can possibly be. So I know it knows that I mean them as factors now. And I'm going to do the same thing with sex, because that was our other factor variable. So I'm going to make it with a capital X, and I'm defining that as the factor of df $sign sex with the lower s. And again, it now knows it is factors where it can only be 0 or 1. So now I want to know, do sex and age make a difference for the response variable, which in this case is probably some symptom of a disease I'm interested in. So I'm going to do a logistic regression model, and the command for this is GLM, that stands for General Linearized Model. And I'm just going to call this Logi model, defined as GLM, parenthesis, response with a capital R. And then the tilde means response is basically the output of it. And then the factors going into it are age and sex. And then I'm going to use family equal to binomial. Data equal df. And now I want to know, I guess it worked. It doesn't say error, but I want to know what it actually says. So now I'm going to use the command summary of Logi model. Any questions so far? So now let me go through what it outputted, because there's a lot of stuff there. So for me, what's most important is determining which factors are actually significant. So I'm going to be looking at the p-values again, just like I did with the t-test. So for age, if I look at that p-value, it's 0.02. I keep forgetting this is a touchscreen. So usually for me, my cap is at 0.05. This is lower than that, so I would consider age a significant factor towards this response. Likewise, if I look at sex, it's also, it's 0.03, but it's still what I would consider significant. And R will actually put in its own little significant curve, so they both get stars because R likewise considers that a significance level. And then they'll put in more stars below your p-value goes to say it's very significant or extremely significant. The other thing I might do is if I wanted to say plot the response as a function of age and sex, I would use this column, which is called estimate. And so I would take age times this number plus sex times this number plus whatever the intercept was, and then I could plot the response as a function of these things. If I had the case where, say, age was a significant predictor but sex was not, what I would probably do then is rerun the logistic model. I'm going to actually do it anyway just for the example. So pretending that sex didn't make a difference, then I would rerun this as response only a function of age. And then I would look again and say, is age still a significant predictor? It probably will be, and this would be the model I would actually print and present, because why include sex if it's not actually significant? Of course, you can have a lot more than two factors going into this, and the rule is, in general, take out the one with the largest p-value, rerun it, until you're down to only those that have significant p-values. Any questions? Because I thought this would take longer, but we still have time. So, since we still have a little time, yes?
Okay, so I'm sorry, I'm less familiar with logistic regression.
Mhm.
So can you explain what the inside of the GLM means? So the formula equals response, blah, blah, blah.
Oh, okay.
That first
Yes, thank you.
Yeah.
So GLM is generalized linear model, and then formula is saying what I want to be. Basically, I'm trying to make a function of age and family that produces result. Of age and it was age and sex. I should scroll up. So I actually put the right thing. But basically, if I wanted to plot response as a function of age and sex, that is my formula. Where this is like the y, and this is what's on going into it. Does that make sense?
Yeah, so you're
And then the family binomial means like the type of function I'm looking at. So you'll notice this would be a binomial function. I only have, it's a polynomial basically. In this case, I only have two things. But you can use other families. There are a lot of different functions that might make more sense for your data. And then data equals df. It needs to know where to find the data because I might have inside the workspace a lot of data. So I need to direct it to the right one. Did that answer your question?
Yeah, I think it did.
Okay. Yes.
At an earlier step, when you did df dollar response, following you, I got error in df dollar response. Object of type closure is not subsettable.
Can I quick look? That looks exactly like what I wrote. Are you using you're using 32-bit, are you also using the 3.3.1?
I just did.
Oh, yeah, that should be the right one.
You should take a look at it, Mike.
Okay, I will work with you at the beginning. Yeah, that is the correct one, so.
No big deal. I just
Did anyone else have that issue? Okay, so one person did. So let me work with the two of you at the end. There's just one more thing I wanted to cover before we switch to the evals. So I guess I'll get the two of you while folks are working on that, okay? And hopefully we can figure out why it didn't work for you. So the one last thing I wanted to mention to you before we go to the evaluations for the class is closing R. Sometimes you'll notice I like being able to press up and get everything I've written before. If when you close you say yes to say workplace image, that will work. I'm going to say no because all the stuff we worked on today is just for demonstration, not like the data I use all the time. But if I were crunching data today and I wanted to crunch the same data tomorrow in other ways, I would say yes. And not only would I have all these functions I used, it would also actually save all the vectors in the matrices. So then when I open it again and I put in weight, it would still have those same weights. So that will actually save you a lot of time if you have to split up working on things during several days. So are we ready for evaluations? And then if I can get those of you who had the issue seeing the different parts of the matrix, I want to see if I can figure that out.
Okay.
With you guys.
So if you wouldn't mind taking some time to fill out a survey, please, that would be really helpful to us. You can also let Dr. Nagle know what you would like to see her cover next week. And as we mentioned earlier, we will be sending out a link to a recording of today's talk, pending any technical issues, but I think it should be fine. And so you will get to review the materials from today's class. But please feel free to stay and help yourself to some snacks, coffee or tea, and talk to your colleagues here, or you can ask Dr. Nagle questions afterwards as well. Thank you for coming.
Thank you, everyone.